All right, let's get right into it. What actually makes a website fast? We all kind of feel it when a site is quick, but the real reason why, the thing that has shaped web development for nearly 2 decades now, is probably not what you guess. When a page is dragging, our first instinct almost always is to point the finger at the server. It must be overloaded, right? Or maybe it's just slow. But what if that's completely the wrong place to be looking? What if the real problem is hiding in plain sight? So this isn't just a guess. The data on this is fascinating. Way back in 2006, a really important study at Yahoo looked at the biggest websites in the world, and they found something that changed everything. Turns out, only about a quarter of the total load time was actually spent waiting for the server to do its thing. The other 75+%, yeah, that all happens after the page arrives right inside the user's own web browser. And that discovery led to what became the golden rule of web performance. It's incredibly simple but powerful. If you want to make a site feel faster for a real person, you have to start on the front end, because that's where the user is, and that's where they're doing almost all of their waiting. This is basically just the classic 80-20 rule in action. Like how 80% of the work gets done by 20% of the people. Well, for a website, it turns out that 80 to 90% of the time a user spends waiting is caused by fetching everything else, all the stuff that comes after that initial little HTML file. So let's dig into where that time is actually going. And a waterfall chart like this just lays the problem bare. See that tiny little bar on the far left? That's the back end. That's your server sending the HTML document. Super fast. But then look at everything else. Every single one of those longer bars is the browser having to make another trip to the server for an image, a script, a font, a style sheet, you name it. So, okay, why is this such a big deal? Why does fetching all these little component parts create this massive traffic jam that takes so much longer than getting that first main document? Because a modern web page isn't just one thing anymore. It's dozens, sometimes hundreds of little things. Every one of these bars represents a separate trip the browser has to make. There's an image, a tracking script, a CSS file, another image, and you can see how they all pile up. Our browser can only download so many things at once from the same server, so they just get in line. It's not one big problem, it's death by 1,000 paper cuts. And think about this. Every single one of those requests goes through its own little ordeal. First, it has to wait in line. Then, the browser needs to figure out the server's address, that's the DNS lookup. Then it has to wait for the server to even start sending a response. That's the time to first byte. And only then can it actually download the file. Now, multiply that entire process by 100. That's why the front end is the real performance battleground. So, facing this exact problem, the folks at Yahoo came up with a set of rules to fight back. This was really the first performance playbook for the web. And what's amazing is how many of the core ideas are still completely on the money today. There were 14 rules in total, but these were the real heavy hitters. And the number one rule, the one that directly tackles that crazy waterfall chart we saw, just make fewer HTTP requests. Simple as that. The other big ideas were to shrink your files using gzip, load your styles first and your scripts last, and get your files closer to your users with a CDN. For a generation of developers, this was basically the Bible. Now, of course, the technology has evolved. Back then, we were on HTTP/1.1, and a browser could pretty much only ask for 2 things at a time from a server. Today, with HTTP/2, it can open a single connection and ask for 100 things in parallel. So does that mean make fewer requests is obsolete? Well, no, not really. The underlying principle just changed a bit. Bundling lots of tiny files into a few bigger ones is still a huge optimization. And here's a great old-school example of that fewer requests rule in action. See those icons? Instead of asking the server for the home icon, then the back arrow, then the forward arrow, that's 3 separate trips, you'd combine them all into a single image, kind of like a little sticker sheet. We called these sprites. The browser grabs the whole sheet in one go, and then you just use CSS to show the tiny piece you need. It was a clever hack, for sure, because one request is always going to be faster than 3. But of all the original rules and all the techniques we've developed since, one stands head and shoulders above the rest. One single thing has a more dramatic impact than pretty much anything else, and that's using the browser's cache. And the difference it makes is just staggering. Seriously, look at this. On the left, a user visits a page for the first time with an empty cache. It has to download everything. It takes 2.4 seconds. On the right, that same user comes back. The browser already has all the assets saved locally in its cache. The load time drops to under a second. It really is true. The fastest request is the one you never have to make. Okay, so you might be thinking that's great for people who come back, but what about that all-important first impression? How many people are really showing up with a totally empty cache anyway? It's a really good question. You'd think it would be pretty rare, right? The answer is actually pretty shocking. Studies have shown that on any given day, somewhere between 40 and 60% of the people visiting your site are doing so with an empty cache for its assets. Let that sink in. For almost half of your audience, every single visit is, from a performance standpoint, like a first-time visit. That first impression matters a lot. And here's the kicker. When they actually tested this, a well-cached page, what they call a primed cache, gave a bigger performance boost than literally giving the user a faster internet connection. It was even faster than turning off all the JavaScript on the page. So the takeaway is crystal clear. Setting up your caching properly is probably the single most impactful thing you can do for performance. Period. So let's fast forward to today. How do we apply these same core ideas with our modern tools? Because the fundamental goal hasn't changed one bit, but the way we achieve it definitely has. We don't really do things like manually creating CSS sprites anymore. Instead, we have these incredibly powerful tools called bundlers. You just point them at all your messy development files, could be hundreds of them, and they automatically handle all those classic optimizations for you. They combine files to reduce requests, they minify them to shrink their size, they basically just automate that entire old-school playbook. And the way we measure performance has totally changed too. We've gone from just running down a checklist to using sophisticated services like Google's PageSpeed Insights. And the critical difference here is that these new tools use field data. This is performance data collected from actual Chrome users out in the wild, visiting your site. So you're not just getting a lab result, you're getting a score based on what real people are actually experiencing. And the focus of that measurement has shifted to what Google calls the core web vitals. These aren't just abstract numbers, they're designed to measure the actual user experience. LCP is basically how fast does the important stuff show up. INP is when I click something, does it respond quickly? And CLS is, does the page jump all over the place while it's loading? It's all about trying to quantify how the page actually feels to a person. So you can really see the whole arc here. It started back in '06 with that huge realization that performance is a front-end game. Then we zeroed in on caching as the most powerful lever we could pull. And now, in the 2020s, we've automated the old rules and we're laser-focused on measuring the real human experience. The tools and tactics have changed, but the core mission has stayed exactly the same. And really, that's the whole point. The tools we use will get better. HTTP/4 will probably come along, the metrics will get more refined, but none of that is the goal. Underneath it all, web performance isn't a technical problem. It's a user experience problem. It's about respecting the person on the other side of that screen and not wasting the one thing they can't get back, their time.